Hello everyone. In this video we're going to be solving a geometry puzzle with calculus flavor. So we do have a circle with radius 1 that's tangent to the x-axis and the parabola y equals 2x squared at x equals a. We are supposed to find a. Okay, so the x-coordinate of the point of tangency, in other words. So at this point you may just continue to watch the video or pause it and give it a try. All right. So we're gonna start by making some connections, and to make it a little easier, I kind of marked those points. So let's go ahead and get started. Notice that this point is the point of tangency, basically. So we're gonna be dropping some perpendicular lines here. Let's go ahead and pick our dotted line again. So let's go ahead and drop the first perpendicular this way, and then we can also connect it to the y-axis so that we can mark the x and y coordinates of that point. So basically, this is the critical point. This is A. We're looking for A, right? Obviously, we might write it in a better way, but anyways. So let's go ahead and connect these as well. See if that's going to help us. And sometimes you may not need all these connections, but guess what? It doesn't hurt to make them, right? So just make some connections. Don't make it too confusing, but, just connect some dots. All right. So what are we going to do next? Well, in this case, I do have kind of like a trapezoid, right? But that's not the whole idea. We got to do something more advanced than that. So let's mark a couple things here. For example, let's say this is our H. And am I going to need another connection? Let's see. I don't think I will need more connections. So I can just go ahead and change this. All right. So what I can do is actually get rid of that and I write it nicer. Okay, A. So now if this point is A, the x-coordinate is A, and since the point is on the parabola y equals 2x squared, this will be 2a squared, right? The y-coordinate. So we're trying to find A. Let's see what we can do. Obviously, if the parabola is tangent to the circle, that means something, right? Okay, so we're going to work off of that. But let's go ahead and do the following first. Let's call this H. And the x-coordinate of the center. What about the y-coordinate? Okay, let's go ahead and connect it to the y-axis. And then you will notice that what that's going to be. So let's make this connection as well. All right, with the dotted line. And then we're going to be getting something nice here. Okay, so what is the y-coordinate of the center, right? Since the circle is tangent to the x-axis, it's supposed to be r. So the center, the coordinates of the center is going to be basically h comma r, which is nice because that's going to help me write the equation of the circle. And I said at the beginning that this problem has a calculus flavor, so we need the coordinates of the center as well as the equation for the circle. Okay? We're not going to be able to use the Pythagorean theorem just like the other problems that we used before. It's just going to be a little different. All right? I mean, we could use it at some point, but that's not the method that we're going to employ here. All right, so what am I going to do? Well, first of all, notice that the point of tangency is a point on the parabola as well as a point on the circle. Therefore, the coordinates of the point should also satisfy the equation of the circle. But what is the equation of the circle? Do we know that? Nope. Well, we can write it. So let's start by that. Let's start by writing an equation for this circle. Well, since I know the center is h comma r, right? It's going to be x minus h squared plus y minus r squared equals r squared. Awesome. Now, since I have an equation for the circle now, I can basically just plug in the point a comma 2a squared because that's a point on the circle, isn't it? Okay. That's a point of tangency, therefore that's a point on the circle. So it should satisfy the equation, or the equation should satisfy the point. All right. X equals a, so I'm going to plug it in like a here. And then the y value is going to be 2a squared. Awesome. If you expand this, you're going to get rid of r squared, so on and so forth, but that's not super important at this point. Okay? Now, this gives us a nice equation, doesn't it? Okay, it does. Cool. But we're going to make it cooler. We need to make it cooler because, first of all, what is r, right? Well, we do know the value of r, by the way. Yeah. Yay. Great. So it says in the problem, that's why we need to read this problem carefully, right? It says a circle with radius 1. So r equals 1. Awesome. So one variable down. What about a and h? There are two variables. So what I need to do is I need to associate a and h here somewhat, right? How am I going to do that? Well, let's go ahead and replace r with 1 first. Let's make our equation look a little simpler. So if r equals 1, then my equation is going to look a little nicer than this, right? Okay, awesome. So this is my equation, but I still have another unknown, which is h. So we have to find the relationship between h and a. What was I saying? I was saying that since this is a point on the circle and the parabola, then we can plug in the coordinates, and we did. So this is one equation we are getting. What is the second equation we need to use? All right, so this is my first equation. I do need another one, okay? Well, that equation is gonna come from calculus. That's why I said this problem has a calculus flavor. Now, let's see what happens. If a function is tangent to another function, you know, what can you say? That means they have a common tangent at that point, right? A straight line. In other words, they will have a common tangent, meaning that the slope of the tangent at that particular point is going to be the same for both of these functions, correct? So you can basically draw a tangent that is common to both of these, and then the slope of the tangent is going to be the same. So what is the slope of the tangent? It is the first derivative at that point, right? So here's what we're going to do. We're going to start with the parabola because it's easier. The equation of the parabola is 2x squared. I'm going to differentiate it, right? When I differentiate 2x squared, as you know, the power rule, bring the 2 down, multiply by the 2 in the front, that's going to make 4, and then bring the power down to x. Okay, cool. So the derivative of 2x squared is 4x, but I need to plug in, so to find m tangent, let's call that m sub d, I need to plug in the x value. And the point of tangency is a. Remember that? A comma 2a squared. So I need to plug in a for that. So the slope of the tangent is going to be 4a at that point. Beautiful. So this is the slope of the tangent from the parabola's perspective. What about the circle's perspective? So I do need to differentiate the equation of the circle. But guess what? You don't have to go into radicals and do something crazy here. We can do an implicit differentiation, right? Take that equation, take this equation, and just differentiate. How do you differentiate? Differentiate everything with respect to x. So this is going to be 2 times x minus h plus, this is going to be a function of x, which is y, or you can call it f of x or u. So bring down the 2, reduce the power, but don't forget to multiply by the derivative of y, which is by chain rule. And the derivative of r squared, because r squared is a constant, as you know, it's 1. The derivative of 1 is 0. Beautiful. Now, in this equation, I have the derivative of y, which is y prime. What I can do is I can just go ahead and solve for that. I can divide everything by 2. And then I'm going to be getting something like this. Y prime multiplied by y minus r is equal to what? If I subtract it, it's going to be h minus x, the opposite of x minus h, in other words. And then from here, y prime is going to be h minus x divided by y minus r. Now, this might look a little complicated because, as you know, it has a lot of variables. But guess what? We're going to plug in some values here. So the derivative evaluated at x equals a is going to be found in an easier way. So, but remember that this is an implicit differentiation situation. So we're not just plugging in the x value, we're also plugging in the y value. So what are those? Well, the tangent is at a comma 2a squared, as you know, right? So I can just go ahead and replace h. Well, h is unknown. So x is a, and then y is 2a squared. And remember, the radius is 1. So that's going to be my slope of tangent from the circle's perspective. Awesome. Now, guess what? These two have to be the same because the parabola is tangent to the circle, or the circle is tangent to the parabola. So what am I going to do next? I'm going to set these equal to each other and get a beautiful, beautiful equation. All right, Cool. Let's do that. H minus a divided by 2a squared minus 1 is equal to 4a. Beautiful. Now I can go ahead and cross multiply. H minus a is equal to 8a cubed minus 4a. And then I can just add a to both sides. Then h is going to be 8a cubed minus 3a. Awesome. This is another nice equation that I would use. Now, all of this basically was for finding h in terms of a, because I do have an equation that relates them right here, but then I would need to replace h with something so that I can get an equation in a single variable, which is a. Let's go ahead and do that now. So I have a minus h squared plus 2a squared minus 1 squared equals 1. So let me go ahead and copy that equation here. So that gives me a minus h squared plus 2a squared minus 1 squared equals 1. All right? So that's my equation that comes from here. All right? And how did I find that? I plugged in the value point a comma 2a squared into the equation. So this basically comes directly from the equation of the circle. No differentiation. Okay, cool. Now I'm going to replace h with that. Let's go ahead and do it. And maybe we can change colors here. Okay, let's go to that one. Replace h with that. So it's going to look like a minus 8a cubed plus 3a. That's going to be squared plus 2a squared minus 1 squared equals 1. Okay. And then I should be getting 4a minus 8a cubed squared plus 2a squared minus 1 squared equals 1. Okay, cool. Now, this might look like a very confusing equation, or it may look very hard to solve. But guess what? One of the good news is that you're going to get 1 as a constant, and that's going to cancel out. Beautiful. And we have more good news on the way coming up. So stay tuned. Okay. So let me go ahead and factor this expression. So what I can do is I can actually take out a 4a, which might make it a little easier to, I think, square. So I can write it like this, right? Then I can square them separately. I can square this, and then I can square that. Awesome. And I can just expand this. So it's going to be 4a to the 4th minus 4a squared plus 1 equals 1. Let's go ahead and expand this, but maybe let's just simplify it first. 16a squared multiplied by 1 minus 4a squared plus 4a to the 4th plus 4a to the 4th minus 4a squared. And I can actually get rid of the 1s already, and I'll get a 0. Beautiful. Let's go ahead and distribute this, and let's see what we get from here. 16a squared minus 64a to the 4th power plus 64a to the 6th power plus 4a to the 4th power minus 4a squared equals 0. A lot of 4s, so you can go ahead and divide everything by 4, but let's go ahead and simplify first by adding like terms. Let's see, I have 64a to the 6th, that's by itself, right? And then I have negative 64a to the 4th plus 4a to the 4th, that should be minus 60a to the 4th power, right? And then, what else do I have? I have 16a squared minus 4a squared, that should be 12a squared. Awesome. Now, the greatest common factor would be 4a squared. Let's go ahead and take that out. If I take out 4a squared, something nice is about to happen. Okay. Let's see what happens here. We get 16a to the 4th minus 15a squared plus 3. Awesome. Everything is awesome, right? Okay. So, what does this mean? Well, this means that a equals 0. Nope, it's not going to happen. So that's not acceptable. A equals 0 is a solution, but unfortunately, we're not going to accept that. So our solutions are going to come from here. That's a quartic, but at the same time, it's what's called biquadratic, maybe? Okay, so it can be turned into a quadratic by substitution. So I'm going to replace a squared with, let's do u this time. Okay, I think we used y another video. So what am I going to get from here? 16u squared minus 15u plus 3. You see, all these problems, after all these manipulations in calculus and so on and so forth, they just turn into a quadratic. Isn't that awesome? Well, it's not always like that, but at least for some of these problems. Okay, so we do have a quadratic. Let's go ahead and solve it. Is it factorable? Okay, here's how we can check. There's something called X method. I think I kind of mentioned it in the comment section in the previous video. So you can multiply 16 times 3, which is 48. And then 48, you put that here, and you put the negative 15 here. Maybe we can do this X method in another video with examples. But anyways, just a quick overview. And then we can look for numbers whose product is 48 and whose sum is negative 15. If they don't exist, then we don't have rational solutions. Okay. Anyways, let's just proceed with the quadratic formula, because you're going to notice that we don't get rational solutions here. Okay, cool. So what is u? U is negative b plus minus the square root of b squared, right? B squared is going to be what? 225 minus 4ac. That's going to be 192, because 4 times 16 is 64. 64 times 3 is 192, all over 2 times a, which is 32. Okay. 225 minus 192 is equal to 33. Awesome. That's why we don't get rational solutions, because 33 is not a perfect square. Okay? 33 is not a perfect square, so we're kind of stuck with this. Okay, fine. Not a problem. Now, both of these solutions are positive, right? You know them from Vieta. We don't even have to check. So, and we know that u is equal to a squared, and we're looking for a, right? So both of the solutions seem valid, at least at this point. They're real. Okay. But we got to check a, because only one of them is going to be acceptable for a value, and we're going to decide on that. Okay. So what happens if a squared equals this guy here? Okay. From here, you take the square root of both sides. Obviously, we're not going to accept the negative solution, so we're only interested in the positive solution. And the way I can do this is basically I can just square root the top, and the bottom is going to be 4 root 2. Awesome. This is one of the solutions. And the other solution is just going to be, you know, a squared is going to equal this minus that divided by this. So my second solution is going to look like the square root of this number. Let me write that. 15 minus square root of 33 all over 32. Or I could just write it just like the other one, right? I can just write it square root of 15 minus, I don't know why I keep writing the 4 there. Okay. Divided by 4 root 2. Awesome. Okay. So these are the candidates, but we have to decide which one is going to be more appropriate. Okay. If you calculate these, and you can kind of do it this way. All right. Square root of 33 is a little smaller than 6. So let's say it's 6. 15 minus 6 is 9. So this is about 3. This is about 1.4 multiplied by 4. It's going to be like 5.6. 3 divided by 5.6 is close to 3 divided by 6, which is close to 1/2. So this is close to 1/2. Okay. It is greater than 1/2, but it's close. So I can say not bad approximation. Okay. What about the top one? Okay, it's kind of like 15 plus 6. I would say square root of 21 or 20 maybe. Square root of 20 divided by square root of 32. So the bottom one was like 5.6-ish, and the square root of 20 is going to be like 4.5-ish. And if you divide that 4.5-ish by 5.6-ish, you're going to get something close to 0.8. Now, we have to decide at this point that which one makes more sense. Of course, there are other ways to figure it out. But if you go back to our picture, is A close to 0.5 or 0.8? What does that look like to you? Well, considering that the radius of the circle is 1, and as you know, the distance between A and H, now let's take a look at this. Look, the distance between these 2 points is obviously less than R, but it's pretty close, right? Well, we don't know the value of A, H, so it doesn't really help us, but look at this. A comma R, right? Here you can see that A is less than R, but it's not too far away. So it's kind of close to R. So in which case, and I checked it for you, don't worry, it's valid, right? The valid solution is going to be the first one. So we're going to go by that, all right? So the A value that we've been looking for is going to be 15, square root of 15 plus square root of 33 divided by 4 root 2. If you want, you can multiply by square root of 2 to rationalize the denominator, but It's no big deal. Well, that's it for this video. I hope you enjoyed it. Thank you for watching. Please comment, like, and subscribe, and I'll see you in the next video. Take care. Bye-bye.